Thank you for coming and spending a few minutes of your time to watch this video. If you got something out of this video, I'd appreciate it if you would just like and subscribe to the channel and just give me feedback on how you thought the content was presented. I'm your host, David Clark. I'm a network engineer with Cisco and Juniper experience, and we're going to be talking about switching basics in this series. So, how does switching work? When we think about switching, how does a switch forward the frames? How does that process work? So, a switch will build and maintain a forwarding table, also known as a bridging table or a MAC address table, Ethernet switching table, CAM table. There's many names for it. But essentially it will create this table for all the destinations within a LAN. The Ethernet switching table is based on the source MAC address for the devices participating in LAN. So when a device connects to a switch, the switch will examine the header of the Ethernet frame, and it will look at the source MAC address, and it will store it in its MAC address table, and it will associate that MAC address with that interface. So when we're talking about this process, that is what's known as learning. When we're talking about switching, there are a few things that encompass switching. Before we get to that, I'm going to talk about layer 2. This is what we're talking about, a few key things, right? We're talking about the data link layer. We're dealing with frames. That's the protocol data unit, this layer. And we talked about the addressing. There needs to be some type of addressing at this layer so that the switch knows how to forward and where to forward the frames. Going on to the next slide, this is what I was describing, the switching process. This is how the switch maintains, it builds and maintains the table so that it has not just a table of MAC addresses, but it also has a accurate, up-to-date table of MAC addresses as well. So we'll go through each one of these. We already kind of described the learning process. That is where the switch is learning the source MAC address of all the devices connected to the LAN. Right, we already mentioned when a switch is first connected to a LAN, it has no information about the devices connected to the network, right? And the learning process, as we mentioned, was just that it was learning the MAC addresses, it's obtaining the MAC addresses of each node on the network. It then stores the MAC addresses in that MAC address table. And we already mentioned how the switch does that by examining the Ethernet header. And this is how it's able to forward based off of what it gets out of the Ethernet header. Right, and there are two other pieces of information that go along with the MAC address that gets stored in the MAC address table, and that is the interface that is associated with it, as well as the time when the MAC address was learned. And that's important for later when we talk about one of the other aspects of it. So we talked about learning and the forwarding. That aspect is essentially how the switch is delivering the traffic, right? It's passing it from an incoming interface to an outgoing interface towards the destination. And to forward the frames to the destination, the switch has to consult the MAC address table so it knows where to forward the frames. And if it has the MAC address in its table, and it has the interface associated with that MAC address, then all it will do is just forward the traffic to that intended interface. One thing that's interesting is what happens when the switch does not have the MAC in its table. Well, what happens, this is known as unknown unicast, by the way. What happens is that it floods the frame out all the other interfaces belonging to the same broadcast domain. And remember, a broadcast domain is just a VLAN. So it sends it out all the interfaces except for the one that the frame was received on. And the next process we're talking about is flooding. Right? So what do we mean by flooding? Flooding is just the process that is used to deliver packets to unknown MAC addresses. So we just talked about the unknown unicast, and that's basically what this is describing, right? So if the bridge table or the MAC address table doesn't have an entry for a particular destination MAC address, or if the packet was received, or if the packet that was received is a broadcast or multicast packet, the switch will flood the traffic out all interfaces except the interface on which it was received. So what's interesting is that the switch will treat these unknown unicast packets where it doesn't know the destination or where the destination address is. It treats it the same as broadcast and multicast. And just remember that it floods it out all the ports except the port that it came in on within the same broadcast domain. And when we're talking about filtering, this is pretty self-explanatory. We're just referring to the mechanism that's used to limit traffic to its associated segment or switch port. The next part is aging, and this is a crucial part to the MAC address table because aging ensures that only active MAC addresses are in the MAC address table. So it's really important to keep accurate information, because if we keep stale MAC addresses in the MAC table, then we can potentially forward traffic towards destinations that may no longer be there anymore, which this is going to cause interruption in traffic, and this is not going to allow communication to happen effectively. So the way that the aging process works, the switch will record a timestamp when the information about the network node was learned. So that goes into the MAC address table, and each time that the switch detects traffic from that MAC address, it'll update the timestamp. So this is good because the first packet that it receives, it stores the timestamp, and then there's a default aging time, and if it doesn't hear back from the MAC address before the default aging time expires, then it will basically remove the MAC address. It'll become stale so that it doesn't forward traffic and possibly cause a loop. The default aging timer is 300 seconds, so that's 5 minutes. That's pretty standard, and you can actually change that. You can configure it for all the VLANs or on a per VLAN basis. And that's pretty much it when it comes to the switching process. These are just the 5 steps that Juniper outlines as how the switching works. And it's important to keep in mind and understand this so that you can be better at troubleshooting, understand how switches work and how they forward and how they're supposed to work. So if you enjoyed this video, and I would appreciate it if you would just like and subscribe. If you have feedback, just put it in the comments section, and I'll see you next time. Thanks. Bye.